When we're talking about sound, we're talking about in increments of 10. So that's why we're still using log. So just like the Richter scale, we're doing it in factors of 10. I think another thing that we're going to be looking at later is going to be when things are acidic. So unlike the Richter scale, though, where we had this IO was 1, when we're talking about sound, we're talking about this factor right here. This negative 12 means 0.000000. Um, well, you can always watch the YouTube video if it keeps kicking you out, Thomas. But probably because I have the virus. Garrett, you gave Thomas the virus by talking about it so much. That's going to be very weird when people watch this in the future on YouTube. But this negative 12 just represents the fact that we have 11 zeros, and this 1 at the end is going to be the 12th digit after the decimal. So that's what we're doing. We're talking about a very, very low-pitched sound. That's the smallest sound the human ear can hear, is that many watts per meter squared. So that's what a decibel is. A decibel is talking about watts per meter squared. In other words, the energy vibrated over what's this form of energy or power? No, it's the form of power. Sorry, power over an area. That's what watts are. So when we're talking about how much is our beta, how much is the difference between these two things, we're just trying to see the difference here. So when we're talking about -1, we're talking about 0.1 watts per meter squared. And we're trying to figure out how many decibels these are. So we're going to compare it to that many decibels. Decibels are basically only what humans can hear. So if we're talking about this much sound, Nick, you're alive. Are you alive? Okay, there you are. Nick is alive. Did you get my text? Okay. Were you asleep? Are you still waking up right now? Well, that's one way to wake up. All right. So we're going to be comparing this to the lowest sound that humans can hear. So just because something is vibrating doesn't mean humans can hear it. So decibels is just going to be a way we can hear something. So if we're comparing something with 0.1 watts per meter squared, this is going to be how we calculate decibels. So this beta that we're solving for is just our decibels, how we solve for it. So moving on here, someone's making an intensity. So how many watts per meter squared? So this is like 0.00026 watts per meter squared. They're just doing it in scientific notation. So when we do this, we're going to do this at, oops, where's my formula? I should have written my formula over here. We're going to do this to the 10th power. So 10 log of this 2.6 times 10 to the -4 watts divided by, sorry, I'm going to have to keep going back and forth, guys, divided by 10 to the -12, or 1 times 10 to the -12, however you guys want to write this down. And this is going to tell us how many decibels this is. So we can use our calculator on the Google calculator, and we can just literally type it all out. 10 log. We're going to do parentheses because we want part of it to be on the top. So part of it's going to be 2.6 times 10. Oops, I don't know where my times went. Times 10 to the power of, what was it, -4? Yep, -4. -4. Close that parentheses because we're no longer on the top. Divided by parentheses. I'm just going to do 10 to the -4. We don't have to put the 1 times 10 to the -4 because 1 times anything is itself. Or I'm sorry, it should be -12. Negative, we're going to do this 10 exponent -12. Close the first parentheses for it being on the bottom. Close the second parentheses for it being inside this log. And our answer ends up being 84 decibels. Does this make sense how to type it into the Google calculator, guys? Yes, no? You agree? Cool. And you're just waking up, so that means everyone else should understand it since they're all awake. So that's how we do this. So when you guys take the test, I recommend writing down for this one the equation for sound. So the difference between sound and the Richter scale, first of all, this number right here at the bottom, this 10 to the -12, that's going to be our I/O for sound. You're going to need this for the test because trust me, the sound thing always threw me off. And you're also going to need to remember that when you're calculating sound, there's a 10 at the bottom, or you're going to multiply by 10. So write down your equations before you take your mastery test. So this is going to be your equation for sound. And if you want, you can even write, instead of that I/O, you can just put this number in there. So you're going to want like a notebook with that on here for this mastery test. That's 84. So now we're going to talk about acidity. So acidity, I don't know if you guys have ever seen acidity. It goes from 0 all the way to 7, right? And the way you can tell, does it only go to 7? I felt like it would go to more. I guess it doesn't. So the formula here, and again, you're going to want to write this formula on, it goes 0 to 14. I knew it wasn't right. So water is 7 because water is right in the middle. It's not acidic. It's not basic. It's just right in the middle. So when you're looking at this, the formula for this is negative log times the concentration of this right here. It's called H3O. H3O just means it's water, but it has an extra hydrogen atom. This extra hydrogen atom, I know you guys aren't really taking chemistry, but if you do take chemistry, I guess this is a little review. Oxygen only has like 2 floating electrons. So what ends up happening here is there's this little hydrogen that kind of like hangs out next to it. But then oxygen's like, I don't have any room for you. So it kind of kicks out this extra hydrogen out, which makes everything more acidic. When there's like oxygen that has like room for an extra hydrogen, it's more basic because it's like, hey, I need something to fill out this hole. So there's a little chemistry lesson for you guys. But basically, all we care about is this one formula right here. How much H3O concentration does this have? Or in other words, how much extra hydrogen do we have? Either way, it's the same thing. I've honestly known this more as how much extra hydrogen we have. This H3O is kind of different. I haven't seen this done before. So basically, when we're looking at this, we're looking at how much H3O concentration this has. So we're going to plug in negative log of this 10 to the -7. Again, I don't like having this 1 times. It doesn't really help us out that much, but you can plug it into the calculator. It'll end up being the same thing, and I'll show you right now. Let's say I have this negative log of 10 exponent -7. And remember, when there's an exponent here, it ends up going to the front. So it's -7. So that's how we get this +7. But let's say I totally forgot about that -1 rule. Like, oh, we don't really need that -1. If I still do this, 1 times 10 exponent -7. Oops, it didn't exponent it. Exponent, exponent, exponent. There we go. I did it, guys. I did it. I still get that 7. I don't know why the Google calculator wasn't agreeing with me. I think I made fun of Google earlier, and it's like, nope, no exponent for you. That's another reason why I do like this calculator, though, is you can see it in here really nicely. So you saw that, like, it wasn't doing the exponent because it didn't write it out. So that's another reason why I like let me close this, like using the Google calculator. So if we're looking at this, we're looking at all these different numbers here. So we can just plug this into our Google calculator and solve for it. So that's like another way to quickly solve using logs. Logs is gonna help us figure out this exponent. What do you notice with the chemical makeup of water? So here we're gonna look at this. If you guys are taking like chemistry and stuff, you probably have used this lab before. If not, this is a good little way for you to kind of mess around with it. So we're gonna play around with this micro lab. So if we add some acid here, I haven't done this in a while, so give me a second. How do I do this? Well, let's get rid. How do I add acid? Oh, hold up. No, I have no idea what I'm doing. Oh, there we go. My bad. So let's see if we do coffee. If I put coffee in here, it says my pH is 5, so it's very acidic. But if I start adding water, look what's happening to my pH level. It's kind of making it more stable. It's decreasing my pH, meaning this water is kind of sucking up some of that extra hydrogen. If I let out some of this combined stuff and add more water, eventually I get closer and closer to that +7. So it's diluting it. So this is why sometimes when you see like acid and stuff, they pour more water into it because the water makes it more neutral. There's never going to be a point where it makes it basic. You're going to need a basic element. So like, let me start. How do I refresh it? Ooh, there's a refresh button. So this thing just measures it. So this is a perfect 7. But let's say I decide to start using spit. So spit is more basic. So if I combine spit and some, this is how I can add more spit to water, it's going to slowly go here. So basically what it's asking us here is, what do you notice about the chemical makeup of water? It makes other other substances get closer to a pH of 7. And in case you're wondering why this H is capitalized, it's a chemical symbol for hydrogen. That's why I've always known it as the concentration of hydrogen. I don't know where they got this idea of using H3O, like I said, it's basically the same thing because it's like, oh, we have water and it's attracting some of this hydrogen. So it's the same thing regardless of it. So it basically kind of neutralizes everything. What are the concentrations of H3O and HO2? So it's basically asking, what are we doing here with this? Well, the concentrations, they're even. So what we can do is like the concentrations of them are even. It's going to be even H3O and even H2O. Let me see if there's another simulator that I'm not looking at here or something. pH scale. Oh, here we go. Let's try micro. This gets way in. This is way too much detail for what we want. We're not taking a chemistry class, so I don't know why it's going this far into it. So when it's asking for this, it's basically going to say that it's balanced. So if we look at the sample answer, it's just saying that this is what it looks like. It's just 1 times 10 to the negative 7. So again, guys, if you guys are a little confused about this, that's fine because we're not really studying chemistry here. So what does it mean by this? It's just asking for the number, the concentration of hydrogen. It's just asking for this 1 times 10 to the negative 7. I don't know why it says and this. We're just talking about the concentration of this. So this is 1 times 10 to the negative 7. That's all we care about. Does that kind of make sense? I know we're not taking chemistry, so it's a little weird. Yes, no, maybe, perhaps. Again, this is very weird. They're just they're basically just telling us that this becomes more neutral. It's made up of this and that. Um, I mean, I guess they really should have told us which one to do because basically, if we look at my solution, if we look at this, it's made up of even numbers of this and that. So apparently we were supposed to be doing this one. Did it tell us to look at this one? What am I? Oh, select micro. That was my bad. Read your directions, guys. Apparently I didn't read the directions. I'm sorry. You guys forgive me? I'll take that as a no. So if we look at this, they're made up of an even number of hydrogen and oxygen. So it's even. So it's even between, and unfortunately, the only way for us to show that little negative is to go H subscript plus and oops and OH exponent negative. So it's even between this and that. I didn't really talk about the OH minus because OH minus is this idea of here's an oxygen and it has this hydrogen here, so it's missing this hydrogen. It has a negative hydrogen ion. This is referring to its electricity or its electrons. Is this kind of making sense, guys? I'm sorry, I'm not a chemistry teacher, and it's been like 5 years since I've taken chemistry, so it's really hard for me to kind of explain this. But is this kind of making sense? No? Yes? Maybe? You guys are all confused? Perhaps. Okay. So basically, the hydrogen and the oxygen are the same, which makes sense because water is just HO2. That's basically what it's talking about. Here, when it's talking about the concentration, it's just talking about how much of this does it have. It has a concentration of this negative 7. When we're talking about this, show the calculation of this. So this, it just wants us to go back to our formula. Our formula is right. Where was it? I know it's here somewhere. It's right here. So when we're typing this in to our answer over here, I'm going to carry this over by doing this. How many extra hydrogens does this have? So if I go to the next one, you guys have the benefit of doing pen and paper. I unfortunately have to kind of write it down and hope it carries over to the next slide. So if we're typing this, show this calculation. We're going to type in negative log of hydrogen plus, and then when we type this in, we're going to do negative log of 1 times, that is not a times, times 10 power negative 7, which would just end up being 7. What's happening here is this negative goes to the front, so we end up getting this negative 7, which just turns into a positive 7. So we're just using the power rule of exponents to bring this to the front, creating this negative 7. This whole thing brings it to the front. Log and log just turns into 1. So log base 10 of 10. What power of 10 gives us 10? 1. That I feel I can explain a little bit better than the chemistry. I'm sorry about the chemistry, guys. I haven't done this in a while. So now we're going to talk about coffee. So if we go here, we want to talk about coffee. Push the button to pour some coffee. So I poured coffee in there. Watch the container fill up with coffee. So we already did that. What's the change here? So the change here is we have a lot less concentration of OH, and we have a higher concentration of this hydrogen. So we have more hydrogen than we have this OH. This is making sense, guys. I'm sorry. I know I could be doing better at this, but I haven't studied chemistry in a bit. I can tell you the math behind it. Watch the container fill up, blah, blah, blah. What is the change? So the change is going to be, when we go from 7, we're going to change to negative 5. So the concentration of our hydrogen, I'm going to do it as hydrogen because honestly, that's how I was taught. I wasn't taught this H3O stuff. So the hydrogen the hydrogen concentration changes to, I'm going to use my little power thing again, 10 power negative 5. So in other words, it changes to an exponent of 2. So confirm this by plugging it in. So in other words, they just want us to plug this into our math. So we're going to do negative log of our hydrogen concentration, which is 10 up negative 5. I don't know why they're having you do this because obviously it's going to be negative 5. I honestly feel this is very repetitive and it gets way too much into the chemistry. So again, if you guys are lost in this activity, don't feel bad. You can see how much I'm struggling just to explain it. So what do you think the concentration of this changes? So we're changing it by a factor of 2 on the pH. The pH is a change of 2. There's a pH change of 2. There's just that much of a difference. So they're talking about that the hydrogens increase. So we're going to talk about the hydrogen atoms increasing and stuff like that. I don't care about that. If you guys just write down the pH changes 2, I'm happy with that. I don't like how they're going really far into the chemistry into this. We can see that this brings our concentration down. It's bringing this concentration up. Don't have to worry about that. I just want you guys focusing on the math more than the actual chemistry, if that's fair. All right, so now this is talking about, okay, so orange juice for breakfast. So this is their concentration. This is talking a little bit more about the powers of 1. I feel this is a lot better than what they were doing before. So if they want us to calculate the pH, they want us to go negative log of, there's 3.4 times 10 to the negative 4 of hydrogen concentration. So we're just going to plug this into Google. That's all we're doing here. We're taking the equation, plugging it into Google. So we do this negative log 3.4 times 10. Close this. That wasn't fun at all, guys. I'm sorry. Exponent negative 4. I feel like they should give a warning there that you should have some chemistry knowledge. So I'm getting a pH of about 3.6 or 3.46, so 3.47, and it's not even multiple choice. Round to the nearest 1 decimal spot. So 3.5 is what I'm getting. 3.5. Let's see how picky it is. Nope, it's not picky at all. Is this making sense, guys? Yes, no, maybe? Cool. The chemistry didn't, though, right? You gave up. I kind of did. It's okay. I kind of gave up halfway through it, but I'm like, I have to teach you guys, so I'm gonna struggle through this. Just watch the video. Watch the video for the answers, basically. Using the properties of logarithms. So now we're going to be talking about this radioactive isotope. So the main thing we're going to focus on here is this right here, this formula. How much radioactivity do we have after a given number of time? That's just AT. How much radioactive material we have after a certain amount of time. This AO, this is how much radioactive material we started off with. So at the 0 point, how much radioactive material did we start off with? E is just our number of exponential growth. The negative just means that we're decaying. So this negative symbol just means that we're going down. R is the rate of change. In this case, our R, this is how much we're going down by every year. The T just represents the number of years. Does that make sense? Yes, no, maybe? Perhaps. No comment? Are you sure? What? Let's kind of fill this in with numbers. So this says we have 10% left after who knows how much time. Nobody knows how much time, right? They're just telling us this is how much we have left. So 10% is the same thing as 0.1. Because if we do 10 divided by 100, we end up getting 0.1. So we're just filling in the gaps here. So that's how much our 10%. And then our rate is this right here. And we're decaying. So it's going to be a negative 0.023 because it's a decay. If it was growth, it wouldn't be a negative. It would be positive. So we're plugging that in there. So that's our rate of change. T is what we're solving for. We have no idea how long this has been there. In case you guys are wondering where this 1 came from, this is how much we had at the very beginning. When this first existed, we had 100%. We had 100 divided by 100, 100%. So that's where the 1 comes from. Is that making more sense? Cool. So that's how we're plugging this in. So then we multiply it by 1, which doesn't matter, but we want to get rid of this e. How do we get rid of e? Well, we're going to have to base it. We're going to have to do a log with base e. Well, log base e is the same thing as ln. So we're going to get rid of this by lnning both sides. So here they're just showing the process of lnning both sides. That's going to bring this t down here. Now we just have to divide by this. They're going to divide it by both sides. And they're going to find out that it's 100 years. Does the process make a little more sense now, guys? Cool. All right. So moving on. So you guys might want to write this formula down. If you guys need like some help, this AT represents amount after. I do not know how to spell after, apparently. After t time. The AO represents amount at beginning. Basically at 0 time. That's why it's a little o. This A naught represents at the very beginning. R is rate of decay. Or growth. It could be for growth too. Negative, the negative in this just means that it is a decay. It is decay. If it was positive, it would be growth. So that's all that negative stands for. And then you guys can guess that this T just represents time that has passed. All right, and then you guys can watch your summary. I recommend watching it to kind of go through all this, but let me kind of do my own little summary here, starting at the very beginning real quick. So here we're just talking about how when something is growing or decaying exponentially, there's a logarithmic inverse that's happening. So that's why they brought up the uranium. So if you guys watch the first video, it's talking about this exponential decay. If we're looking at the inverse, lead is being populated. So that's why there's a logarithmic function here. There's a log function going on here. That's where this is coming from. The log is coming from a creation that's the opposite of this decay. Growth in money. So money is an exponential growth, but if we want to figure out how much time it takes to get that much money, we're going to have to do log. We have to do log to kind of get rid of it. When we're talking about learning something, that's this idea that we're learning really quickly and then we kind of start flattening out, right? We don't know anything and then we learn really fast and then we just kind of start bottoming out. Going on. So again, the inverse of an exponential growth is a logarithmic function. We have to use logs of the same base to kind of cancel it out. And then here's our log rules again. So if you guys don't remember the log rules from the last one, they repeat it here. Going here, it's just talking about the changes in this. So if we're doing exponential growth, this A just represents our starting amount, our A naught. So the A just represents how much we start off with. The B is our growth factor after X amount of time. And then we can talk about if it's a fraction, it's an exponential decay. If it's a whole number, it's growth, log, and the changes in logs. So this is talking about the Richter scale. Remember the Richter scale, the I naught, the intensity, is always a factor of 1, and then we're going to include this. So the Richter scale is similar to our decibel scale. So our decibel scale was over here. The only difference is we're going to multiply it by 10. And our naught, our I naught, our intensity is this 10 to the negative 12 right here. That's going to be our I naught. So when you're writing this formula down, remember our I naught is different. For Richter scale, it's 1. For this one, it's negative. And also this one has a 10 at the beginning. Then we're going to do the calculation. Chemistry, this is the formula of negative log of our hydrogen concentration. And that's all it is, basically. They're going to give you a number for this hydrogen concentration, or H30 plus. When you guys go back to doing your tutorial, you guys are probably going to have to want to fast forward to this to get all the answers. And they're right here if you guys want to do it the way they do it, or you can do it the way I explained it. That's fine. And these videos are going to be up later, by the way. The concentration of this goes up, the other one goes down. I think I just explained it as it neutralizes it. This one, it's just going to be 5. Like I said, I feel like this was a waste of time because the exponent was 1. I felt we learned more when we were talking about the next one. So this one here, obviously, they're even. We're going to decrease it, or it can go up if it's... So basically, if it's basic, we're going to increase the hydrogen concentration. If it's acidic, it's going to increase this concentration. That's all it's talking about. Water kind of brings them more to the middle. This one I felt was a little bit easier when we did it. Or not easier. Technically, it was a little harder, but it made more sense. We learned more plugging this in. And then this is how we can explain this part. So do you guys have any questions on it? Yes, no, maybe? Yeah, the chemistry was... They really wanted to start teaching you guys chemistry there for some reason. Like, I'm like reading it, I'm like, why are we trying to teach them chemistry? We need to teach them numbers. So if you guys are stressed about the chemistry thing, yeah, it's a little weird. I'm sorry. Function activity. I'm going to take some time to kind of go through the unit activity here because I know that's usually where people struggle the most with this. So you can look at the software editor here if you want, but I feel this kind of makes it a little weird. It's just talking about number lines and stuff like that. But let's kind of get into this activity a little bit. So this first thing, this is a paper. You guys are going to have to read it, and you guys are going to have to write about it a little bit more. So you want to include how we can calculate it with the power of tens and stuff like that. Read it. I'm not expecting a whole lot. I'm just expecting you guys to at least answer these questions. How was it discovered and when? How can we calculate that value? Why do we use E? One specific real world example. So this is what I really want. Just this, and this. It doesn't have to be too involved. You could literally write like a little sentence about this. Maybe like a couple sentences, to be honest. Couple sentences about this. Couple sentences. That's all I really want. I just want you guys to answer these questions. Is that fair? Okay. And then here, this is going to show you the answers. So growth factor, when we're talking about a growth factor, we're talking about this percentage. Is there a way I can look at this without showing you guys the answers? There we go. Give me a second. Let me open this up. Save as PDF. If you guys need help with this, let me know, but I'm going to open up this PDF right now. Because I just don't want to like show the answers on camera since I'm still recording. If you guys need help with it, you can always make an appointment with me and I can go over how to do it, but I just kind of don't want to put the answers on this video for a graded assignment, if you know what I mean. How do I do that? Downloads. There we go. Downloads. Did it not save it? Where did it go? It was supposed to save it. Hold up, guys. I'm sorry. There it is. I don't know why it's called functions when it's focusing way more on logs. Okay. So what is the growth factor of the town? So the growth factor of town. This one's pretty simple. They're literally telling us what the growth factor is. This, is there a way for me to write on here? Oh, there we go. No, that's not it. Oh my gosh, why didn't this just open up with the thingy? Give me a second, guys. Open with Chrome. What are you doing? My computer doesn't like me, guys. I'm sorry. There we go. That took like 5 years. So what is the growth factor of this? So again, this question, very easy. It is literally, why isn't this showing me my tingy? Oh my gosh, now it's not letting me write. Why does my computer hate me so much? You guys saw that it was here like all, okay. This hates me. I can't even write on it. Why can't I write on this? All right, so the growth factor is basically right here. You're just going to change this to a decimal basically for this activity. Write an equation using the model, and it still gives me the answers. Great. Write an equation for the model. So you're gonna go back and look at exponential growth model and write that in there. And it literally just wants the exponential growth model. It literally wants something like this. You're just plugging it in. So this stuff isn't that bad, guys. Like, I know I've gone over it a few times, but that's pretty much it. Since apparently there's no way for me to do it without putting the answers up on YouTube. If you guys really need help with it, make an appointment with me and we can go through it. But write your essay first. That way I don't have to explain how to do the essay part. Is that fair? Yes, no, maybe?